Okay, guys, so yesterday we went over mole equation stuff. Okay, quick review of the stuff that we went over yesterday. Okay, a mole is what? Okay, it is a measurement. It tells us how much of something there is by referring to essentially a specific number of particles. Anyone remember what that specific number of particles was? Gage. 10 to the 23. Yeah, right, this one here. Okay, and this is Avogadro's number. Okay, it tells us the number of particles in 1 mole. If we're dealing with a compound, those particles are molecules. If we're dealing with an element, those particles are atoms. Everyone follow me there? Okay, so that's a couple of the things that we've got to remember. Okay, next thing we got to remember, the mole equation itself. N equals little m over big M. What does N stand for? Number of moles. What does little m stand for? Okay, mass in grams. And what does big M stand for? Molar mass. And what are the units for molar mass? Grams per mole. Right. Where do we get molar mass from? From the periodic table. So you'll never have to solve for it using the mole equation, but you'll always need it when you use the mole equation, but you can always get it off the periodic table. All right? Everybody following me there so far? Okay. When do we use Avogadro's number? When they talk about molecules. If the question gives you the number of molecules, or the question asks for the number of molecules, then you will have to use Avogadro's number. You won't use it in any other situation. Okay? The reason we use Avogadro's number is either to get the number of molecules, or if given the number of molecules, to find the number of moles, okay? Because Avogadro's number tells us the number of molecules or particles in a mole, all right? So we're either going to use it to find the number of molecules we have or particles we have, or we have been given that and we'll have to go backwards and find the number of moles that we have, okay? So it's always going to be tied to number of moles. You're either going to be multiplying Avogadro's number by the number of moles, or you're going to be dividing the number of molecules by Avogadro's number to get the number of moles, one or the other, okay? But that's the only way you'll ever use it. It's never part of N equals little m over big M. It's always an extra step either before or after that. All right, what I would like you guys to do right now, actually, sorry, before we do that, I told you yesterday all about this review package, this wonderful thing I was going to give you, and then I forgot to give it to you, okay? So I'm going to give it to you right now. Okay, the review package you have has essentially 2 parts. Okay, the first page is basically review activities that I'm recommending for you to do. So some of them are questions to answer, okay, you know, things like that to just have you practice some of the skills that are necessary. That's the first page, okay. Some of those are even things that have been on exams in the past, right? The second, third, and fourth pages are actual old exam questions, okay, some of them multiple choice, okay, and on the very back here you can see there's some old written response questions as well, okay. So make sure that you are at the very, very least, okay, I say that because I don't want you to think just doing this is enough to study for your unit exam, but this is a very, very good start, okay, at the very, very least do this, all right, at the very, very least. There is a key for it, and it's on my website. Okay, so if you go to my website here into Science 10 stuff, in the chemistry folder, it is the very last file in the chemistry folder. Science 10 Chemistry Unit Exam Review Key. All right, so if you click on that, okay, it'll call up the file, and you can see that I've got answers, okay, in green or in my very messy handwriting for all of the questions. Okay, I even have the correct answer for the multiple choice highlighted in green. I think there's just the last couple of questions I didn't get around to actually getting answers for. Okay, I will do my best to get that done at some point over the next little while, and then I'll update this file. Okay, but if I don't get to it, I don't get to it. But yeah, I'll do my best to get it done. But you can see that much of it is there, so you can use that. And this will give you a pretty good idea of how I'm going to word things. Okay, and what kind of questions I'm going to ask, what level of difficulty to expect, all right? Because I think I've told you guys before, I'm not very creative, okay? So, you know, These questions are going to be basically like the questions that will be on your test, except slightly different context or slightly different situation. All right. All right, so that gives you a pretty good idea there of what to do. Tomorrow, we'll have our unit exam review. Okay, so I will basically tell you, here's what's on the test, here's the number of marks, that kind of stuff. So you'll have a pretty good idea of what kind of things you'll want to do over the weekend in terms of preparation. My recommendation for you for tomorrow is this. Look over your quizzes tonight. Okay, so look in PowerSchool and look at your quizzes. If there's a quiz you didn't do well on, look at what it was about. Okay, and ask about that tomorrow. It's only going to take me about 20 minutes to get through explaining to you what's on the test. Okay, so there'll be time for kind of Q&A after that. Right? If you've got questions, that's the time to ask. Right? The other thing that we're going to do tomorrow is we're going to go over your reaction lab reports. Okay, which I've kind of been looking at a few of them here. Okay, I don't have all of them yet. Okay, make sure I get them very, very quickly. They were already supposed to be due. Okay, so make sure that that happens. So just, yeah, make sure you're getting all of that stuff done. Reminder also that your toxin project is due on Monday. Okay, hopefully you've got that pretty much done already. And then the reactions worksheet, or sorry, reactions assignment that I gave you the other day that you had all of class to work on, that's due on the 8th. All right, there's no rush on doing that before the exam. Okay, make the exam and your toxin project your priority for getting done. Okay, questions on any of that? Okay, I want you to try these mole equation questions here. I'll let you get ahead of me, okay, and then we'll go over them. These will be the 4 solved examples that you will get today. You got 4 yesterday, you can get 4 more today, you can get 4 more on Monday. All right, so you'll have 3 examples of each type of mole equation question that I could ask. All right, so give these ones a try, see if you remember from yesterday how to do them, and then we'll go through them together. So number 1 is an example of the easiest, most basic type of mole equation question. All right, how many moles? All right, so they're asking us calculate N of calcium carbonate. Since they tell me the material, I can calculate the molar mass, big M. Okay, calcium is 40.08, carbon is 12.01. How many carbons are there? 1. Okay, how many oxygens are there? 3. Okay, so when we've got those, we add them all together. Okay, so we got 40.08 plus 12.01 plus 48. That's 16 times 3. Okay, so 100.09 is our molar mass in grams per mole, right? All right, they also tell me 125 grams. Anything measured in grams is mass, little m. So I have little m, I have big M. The mole equation is N equals little m over big M. I don't have to do any manipulating, I just need to plug in my numbers. 125 grams divided by 100.09 grams per mole. Okay, and guys, honestly, I don't expect that you put units in your calculations here. If you do, fine, but I always do it just out of habit doing the thorough example. Okay, so that should give us 1.25 moles. Ashley. In the givens, I'm less worried about it in the givens. I'm most concerned about it on your final answer. If you don't have in your final answer is wrong, because I don't know whether it's moles or elephants with arthritis. Okay, I need to know what I'm being told there is. Okay, questions on number 1? How many people have done number 2? Okay, how many people need just a few more minutes? Okay, I'll give you a couple more minutes on number 2 before I do that one. So on number 2, they're asking, what is the mass? So what of the 3 things are we looking for? Mass is which one? Little m, right? Okay, so little m, they tell us the number of moles, which is N, 2.7 moles. And they tell me the material, lithium phosphide. Okay, so that's going to mean we got 6.94, okay, times 3, because we got 3 lithiums, and we got one phosphorus, 30.97, is that right? Okay, so we add those ones together. And so we got 6.94 times 3 added to 30.97. So 51.79 grams per mole. .79 grams per mole is our molar mass. Okay, we have N and big M, and we're looking for mass. Since the mole equation sets up to calculate N, we need to move some stuff around. Which thing do we need to move? Big M. How do we move that? Okay, crossing it off, putting it over there. Okay, so essentially multiplying both sides by big M. Okay, because if I want to move something, I do the opposite, right? If I'm dividing by M and I want to move it, I multiply. And then what I do to one side, I do to the other. All right. Little m equals, okay, big M, which was 51.79, multiplied by the 2.7 moles that I was given in the question. Okay, and that should make sense. If I know that 1 mole of this stuff has a mass of 51.79, and I've got 2.7 moles, it should make sense that by multiplying them, I would get my total mass. All right, it was kind of like the elevator, people in the elevator example I gave you the other day, right? If you know that every person, the 6 people in the elevator all weigh 200 pounds, you got how many pounds in the elevator? 1,200 pounds, right? Okay, that's what we're doing here. All right, so we multiply those two. And we got 139.83 what? Grams, right? Okay, so that would be 1 mark for that, 1 mark for your manipulation, 1 mark for plugging the numbers in, 1 mark for the answer, so likely a 4 mark problem. How many people have done number 3? Okay, I'll give you a few more minutes on number 3 before I do that one. All right, so on number 3, we've got a question asking how many molecules. So what's going to be needed here? Avogadro's number, right, this thing. Okay, Avogadro's number, the mole guy. Okay, we got to use his number for this question. What we got to do is figure out, are we dividing by it or are we multiplying by it? Okay, so first off, let's look at what we've got. They tell us the material is iron 3 oxide, okay, which means I can calculate the molar mass. So 55.85 times 2 plus 16 times 3. Okay, so 159.7 grams per mole. Okay, so I've got big M. They also tell me M, little m, right, 230 grams. All right, if I'm not sure where to go from here, I have big M and little m. What does my mole equation formula say I should do with those two numbers? It says I should divide them, right? That's what it's set up as. It says N equals little m over big M, which means I can calculate, not whatever I want there, okay? I can calculate number of moles. Everybody follow there? All right, so all I have to do is plug in my numbers. I don't even have to manipulate. 230 over 159.7 grams per mole. All right, is 1.44 moles. All right. At this point, I know I got to use Avogadro's number. Which makes more sense? I want to find the number of molecules. Should I divide by a number that represents how many are in a mole, or multiply by a number that represents how many are in a mole? Multiply. Okay? In the same way that if you were trying to figure out how many dozen donuts you had if you had 4 dozen, if you're trying to figure out how many donuts you had if you had 4 dozen, you would go 4 times 12. Okay? And you get 48. So in this case, that's what we're doing. We're going to take the number we have multiply it by the number in a mole, and that'll tell us how many molecules we've got. So number of molecules is going to equal 1.44, our number of moles, multiplied by the number of molecules in a mole. And remember, when you're entering Avogadro's number, it has to be enclosed in brackets, 6.02, and then the little E button with a 23. If you're using your phone because you forgot your calculator, don't forget your calculator on Tuesday. You're going to be up you-know-what creek with no paddles. Okay? You need to turn it on its side. If you turn it on its side, the scientific functions show up, and one of them is capital E, capital E. That's the button you want to press if you need to do it that way. All right. So now that we've got that, okay, we find that we have 8.67 times 10 to the 23 molecules. How important is it for me to write molecules on that answer? Very, otherwise it would be wrong. Okay, or elephants with arthritis or whatever. Okay, either way it's meaningless, so make sure you've got units on it. Questions on number 3? Okay, how many people have done number 4? All right, I'll give you a few more minutes on that one. Okay, number 4 also asks about molecules, or actually gives you molecules, so you're probably going to be using Avogadro's number again. Okay, so number 4 is as involved as a mole equation problem will get. Okay, you have to do the most manipulating, the most extra steps. Okay, this is the big daddy of all, okay, mole equation questions. They tell us in our givens the number of molecules. Okay, and that's 5.42 times 10 to the 21. What I have to realize is I always know how many molecules are in 1 mole. It's whose number? Avogadro's number. Okay? I always know this number, and I always know what it represents, the number of particles in 1 mole. So if I know how many particles I have, and I know how many are in 1 mole, can I find how many moles I have? Yes, by doing what? Multiplying or dividing? Dividing. Okay? All right, so I'm going to find n right away. Okay, that's my first step. Find n because I need it if I'm going to find mass, because I need it for the mole equation. So 5.42 times 10 to the 21, the number of molecules, divided by the number of molecules in 1 mole. Okay, will tell me the number of moles. Is it okay if this is a really small number? It is. I mean, look at these two numbers. This one on top is way smaller than the number on the bottom. Okay, in fact, it's a factor of several hundred times smaller, right? It's 10 to the 21. This is 10 to the 23. They're 2 factors of 10 different, okay? And 10 squared is, ooh, I was really looking for an immediate answer. 100, right? Okay, so these are a factor of at least 100, actually several hundred times smaller than each other. All right, so when we do this and we punch it into our calculator, okay, we have 5.42 to the power of 21 divided by Avogadro's number. All right, 9/1000ths of a mole. Okay, so very, very small. Right, a very, very small amount of this stuff. Decimal 0.009 moles. Okay, I have N, and the other thing they told me was the material. What can I get with that? Molar mass, right, I got big M. Okay, so nickel 2 nitrate is the stuff I'm dealing with. How many nickel are there? 1, okay, and nickel is what, 58.69? Okay, how many nitrogen do I have? 2. And how many oxygen do I have? 6. Okay, we put all of those together and we got molar mass. So 58.69 0.69 plus 28.02 plus 16 times 6 is 182.71 grams per mole. So next step then is to calculate our mass. Mole equation sets up like this. I want to isolate little m, so I do that by multiplying both sides by capital M. So little m will equal 0.009, the number of moles, multiplied by 182.71, the molar mass. Okay, we're obviously not going to have very much of this. 1.64 grams. Okay, so yeah, we didn't have very much of it. All right, like I said, that's probably a 5-mark question, all right, because it's got the most steps in it. Your unit exam will have 3 mole equation questions on it. Okay, so I will ask you 3 out of the 4 kinds of mole equation questions. Of course, you won't know ahead of time which 3 I'm going to ask, so you do need to know how to do them all. Okay. All right, questions on how this stuff works. Okay, like I said, we'll go through another 4 on Monday. For right now, I'm going to give you the worksheet and have you start practicing this stuff. All right, so on your worksheet here, the first few questions are actually a little easier than what we just did. Okay, the first few questions simply involve remembering what's a mole and how much of everything is in 1 mole. All right, so for question 1A, for example, it wants to know how many atoms or molecules are present in each of the following. We said anytime they want to know the number of molecules, what are we doing with Avogadro's number? We're multiplying. Okay, so how many atoms of gold are there in 1 mole? How many atoms of anything are there in 1 mole? Exactly. Okay, 6.02 times 10 to the 23. All I did for that question was go 6.02 times 10 to the 23 times 1. Exactly. There was only 1 mole. In fact, would it have made any difference what element I put there? Nope. Wouldn't have made any difference. I could have put iron there. I could have put nickel there, copper there. It wouldn't have mattered. Okay? There's the same number of atoms of anything in 1 mole of that stuff. Okay? Unless we were dealing with like a molecular element where it bonds to itself. Right? But essentially, 1 mole is always 6.02. All right. So what are you going to have to do in number 2 then when you're finding 2.5 moles of helium? Just multiply it by 2.5. Okay, is that pretty straightforward? A lot of people really overthink that question and they show like a page of work to get the wrong answer. Okay, all you got to do is multiply by Avogadro's number. Okay, number 2 is a little more like what we've been doing. Okay, a little easier, but a little more like that. You're going to have to use the mole equation for number 2. Okay, you won't need Avogadro's number unless you're looking for number of molecules or you're given the number of molecules. All right, so make sure you're not overusing his number. Okay, there's a key for this, guys. It's on the website if you want to check your work as you go. Okay, so it's same place, Science 10 stuff in the chemistry folder, and it's called Keys to All Mole Equation Worksheets, right there. All right, so you can check them as you go and see if you're doing them right. Okay. All right, so looking at question number 4, it says, what's the mass of 3.01 times 10 to the 23 atoms of copper? So they gave me the number of particles. All right, what do I need to do with that? I need to use whose number? I got to use Avogadro's number. And am I going to divide it or multiply by it? I'm going to divide by it. Okay, this is the number that I have, and Avogadro's number tells me how many are in a mole. So by dividing, that'll leave me with the number of moles. Now, I'm not even going to bother punching that into my calculator. I can look at this right now and know it's exactly how much. Half a mole. This is exactly half of Avogadro's number, since his is 6.02. Okay, so N equals 0.5 moles. They told me it's copper, so I go over here and I look up copper's mass, 63.55. So I know big M. Okay, now I should be able to calculate little m because it's big M times N. So half of 63.55 should give me the answer. All right, 31.78. Okay, grams would be our answer there. Sorry, 31, not 38. 31.78 grams. Okay, is that making sense? Remember, anytime we're given atoms, molecules, we're going to be using Avogadro's number. Okay, if you're given the number of molecules, you're going to divide by it. If you're asked to find it, you're going to multiply by it. Okay, simple as that. Just got to remember it. Any other ones there, guys?